Hello and welcome. This is Malachi Bishop. This is Rehabilitation Counseling Research and Program Evaluation Week 4. This week we'll be talking about the fundamentals of measurement and statistical issues, and we'll be talking about reliability and validity. This week we'll be focusing on quantitative research. Last week we talked about qualitative research design and methods. Like qualitative research, conducting a quantitative research project also involves multiple steps and components, not necessarily in the following order, but the steps and components that we'll be talking about this week include the following. What is my research question or hypothesis? And we talked about developing a research question and hypothesis, and we talked about what those terms mean. So that would be the first step in coming up with a quantitative research project and conducting such a project. Second question is, what will be the research design? What's the appropriate design? What variables am I interested in, and how will I operationalize the variables? How will I measure the variables? What will be the best sample to evaluate in order to answer my questions or test my hypothesis? And what are the best procedures to answer my questions? And then making decisions about statistics. So we'll be talking about these various steps this week. Remember, last week we talked about several qualitative and quantitative research designs. In quantitative research designs, we talked about descriptive, correlational, experimental, and quasi-experimental designs. So the next questions that we would want to answer include, what variables am I interested in, and how will I operationalize the variables, and then how will I measure the variables? So let's talk about operationalizing and measuring the variables. Remember, variables are characteristics of persons or things that can take on two or more values. So a variable has two or more values, and variables can be distinguished by their measurement characteristics. They can be categorical or continuous. And categorical variables have values that may be one of a limited range of characteristics. Things like gender and marital status, we measure those usually in terms of a limited range of characteristics, generally either male or female for gender, for example. Two options, two categories. With marital status, we might talk about married, never married, divorced, separated, widowed. We can come up with a number of possible categories to describe marital status, but it is a limited range of characteristics that we would be identifying there. So those are examples of categorical variables. Continuous variables may take on any value on a continuum. So things like age and income. Let's also talk for a minute about independent and dependent variables. This is these are ideas I'm sure you're very familiar with, but sometimes people get confused about which is which. The important thing to remember is that the independent variable is the variable that is manipulated or changed by the researcher as part of the experiment, and the dependent variable is what we measure to evaluate the effect of the change in the independent variable. So the dependent variable, the response being measured, is the response being measured in the study. In social science research, the dependent variable typically involves either observation or self-report measures or measures of physiological response. So just remember, the independent variable is the variable that the researcher manipulates, and then we measure the effect of that manipulation on the dependent variable. You can also think of it as cause and effect. The independent variable is the cause, and we measure the effect of that by measuring the dependent variable. You'll also see process and outcome variables. Process would be the independent variable, outcome would be the dependent variable. Sometimes you'll see predictor and criterion variables, and these refer to the same ideas. Predictor variables, same as the independent variables, and the criterion or outcome variables are the dependent variables. And another way to think of it is that the independent variable is the intervention, and the dependent variable is the results or the scores, the thing that we measure to evaluate the effect of the intervention. And then the next step in the process is to think about the appropriate way to measure our variables. How do we measure the variables? And in rehabilitation counseling research, we generally have a lot of options. But it basically boils down to either using an existing measure or instrument, or developing our own way of measuring a variable. For a lot of the constructs that we would be measuring in rehabilitation counseling, which might be things like quality of life, work satisfaction, for example, there are measures that we know have good psychometrics, they have good reliability and validity, they measure what we want to measure, and so frequently it is efficient and useful to use an existing instrument, an existing measure. Sometimes, however, there is not an instrument available to measure what we're trying to measure. There is maybe we're measuring a construct that a measurement exists for, but it's not quite right for what we are doing, and so sometimes researchers have to develop their own instrument. The problem with that is that when you develop your own instrument, you don't know if it is going to be reliable and valid, so you have to evaluate that as part of the research that you do or prior to doing the research. Sometimes with pilot testing, for example, we have to evaluate the reliability and validity of the measure that we developed. But as I said, there are a lot of existing measures that we can use in rehabilitation counseling. And if you're in the vocational evaluation course, if you've had that, you've talked about a number of tests and questionnaires that you might use for research, measuring things like aptitude, vocational or educational aptitude, achievement tests, personality inventories, interest inventories, measures of mental health, so instruments to evaluate depression, anxiety, things like that. A lot of instruments exist to measure mental health constructs. There are also a lot of instruments available to measure quality of life and all the various ways that we measure quality of life, health-related quality of life and life satisfaction and things like that. There are many quality of life instruments already in existence, but we also keep coming up with new ones. And then satisfaction, client satisfaction, consumer satisfaction with services, things like that. So there are a lot of existing instruments available to measure our variables. The important issue when thinking about the instrument that you are going to use to measure your variables for your project, your research study, is, are these instruments reliable and valid? We want instruments that are reliable and valid so that we can rely on and have faith in our results. So let's think for a minute, talk for a minute about reliability and validity. Again, I'm sure you've probably heard these terms before and have some familiarity with the ideas. So we will talk briefly about these. Reliability refers to the consistency or dependability of a measuring instrument. This means that the extent to which the same test would give the same results for the same individual over time. And people often think of the bathroom scale. If you have a bathroom scale, you step on it one morning and it says you weigh, let's say 150 pounds. you would expect if you stepped off and stepped back on that you would still weigh about 150 pounds, and tomorrow morning if you step on the scale again, you would expect to weigh about 150 pounds according to your scale. And if that is happening, then you probably have a fairly reliable instrument there. But when we're talking about more complex constructs like psychological constructs, and we're measuring these among human beings, then it is rare to get the exact same score on most of the tests that we use in rehabilitation counseling. It's rare to get that kind of consistency because people and constructs that we're measuring are complex. There are a number of reasons why it is unlikely that a person who takes, for example, an intelligence test, if they took the same test a week later, would get exactly the same score. And that's because reliability is associated with two elements: the true score and error. And the true score you can think of as if the tests were perfect and an individual took an intelligence test, that the true score would be precisely how intelligent they are according to that scale. But when we give somebody an intelligence test, what we really have to take into account is that we're probably not getting their best score. We're not getting their actual true score. We're probably getting a score that is within a range of their true score, where they really would lie if all the conditions were perfect and the instrument was perfect. We really should think of these instruments as a best approximation. So why would an instrument not give the same results over time? Or to think of it another way, why would an instrument give different results for two people who are basically the same in terms of the construct that we are interested in measuring? And the idea is that there are a lot of potential sources of error. There are error sources associated with the person taking the test or completing the measure. There are error sources associated with the instrument itself, and then there are administrative issues that can create error. So in terms of person sources, we're talking about the fact that let's say the person is feeling tired or having emotional problems, or for various reasons related to disability or functional limitations, wasn't able to give their best effort, and thus the score doesn't reflect their true score. All sorts of potential issues there in terms of issues within the person. And then there are certainly instrument related issues. If the questions on the test are worded confusingly or ambiguously, then you're probably not going to get the true assessment of the individual's performance or capacity. The questions can be too easy, too hard, too long, too short, and so on, but there are problems with the instrument that make it impossible to accurately assess the individual's true score. And then if the room isn't lit quite right, if it's too warm and it makes the person feel sleepy, or too cold, or too noisy, those sorts of issues in the administration of the instrument can also lead to error in finding the person's true score. So these sources of error create a lack of reliability. They can affect reliability. And if an instrument is reliable, then it is less likely to be affected by these sorts of sources of error. And some tests, some measures that you might use, some instruments are more susceptible to sources of error than others. But it is impossible to produce a totally reliable psychometric instrument. The scores will always differ somewhat. They will always be somewhat unreliable. With a reliable test, the scores will be basically more similar over time if the person took the test again. But it's impossible to have a truly perfectly reliable psychometric instrument for those reasons that we talked about. But it's important that we evaluate the reliability of an instrument. And there are several ways that we do that. When we do that, we usually talk about reliability, evaluating reliability in terms of a correlation coefficient. So you will see the reliability of a test reported in terms of a correlation coefficient ranging from 0 to 1. And basically, the higher the coefficient is, the closer it is to 1, the more reliable the instrument is. So what is an acceptable level of reliability? Would a reliability coefficient of 0.6 be acceptable? Generally, we would not place a lot of faith in an instrument that had a 0.6 reliability coefficient. Generally, we are looking for a 0.8 or higher, though this does depend on the circumstances of the research, the instrument, and the method being used. So there is some variability in here, certainly, but generally we're looking for around a 0.8 in social science research or higher. Let's look at the three different methods of assessing reliability of an instrument: the test-retest method, the alternate forms method, and the various internal consistency methods. The most direct method of evaluating reliability is to administer the test to an equivalent group of people at two different times. So you would give a group of people the assessment or instrument, have them complete the instrument, and then at some time in the future you would have them complete the instrument again, and you would basically correlate their scores to see how well they correlated, and that would be a measure of the reliability of the test over time. And this is a fairly frequently used method of evaluating reliability. The issue here is to consider how much time elapsed between the two administrations of the test or instrument. If you do it too quickly, like within a few hours, then you could have issues with fatigue, for example, people just getting tired, and also practice effects, and that they just took the exam, they're going to, or the completed the instrument, they're going to remember the questions and be more prepared to answer them. So the performance would probably be not as good if they were tired because it was a long test and they just took it a couple hours ago, or it would be much better than you would expect because of the practice effects and the fact that they were already familiar with the content. So there are also issues with waiting too long, in that the group of people might change in terms of the construct that you're trying to measure. A lot of psychological constructs are fairly consistent over time, and that would be less of an issue for some things, like, for example, intelligence tends to stay fairly consistent. But if you were evaluating something that's more fluid, like mood, anxiety, depression, something like that, then if you wait too long, then it's likely you could have significant changes within the group, and so that would affect the reliability of the evaluation too. Generally about 2 weeks, but there's no rule, but it's generally about 2 weeks between administrations. Sometimes you see longer, sometimes shorter, but generally around that time, a couple weeks to a few weeks between administrations. So that's one method of evaluating the consistency of an instrument over time. Let's look at the alternate forms method. And this approach, the idea is that two alternative forms of the assessment or test or measure or instrument are developed, and the idea is that they will have different items, but they will be equivalent. So for example, I've developed two alternate forms of a test here, test 1 and test 2. And let's say it was an aptitude test, and so I have some spelling items. I asked people in test 1 to spell the word cat, and I would ask people in test 2 to spell the word dog, and then robust and rebate. And the idea is that it would be equally easy or difficult to spell those words. And the way you would find that out is you would develop the test and then have ideally a large number of people complete it, and you would evaluate whether people who got the spelled cat right, also spelled dog right, and people who spelled robust wrong, also spelled rebate wrong, for example. So you would evaluate whether the items that you selected were in fact equivalent. Eventually, though, you would get to where you had some confidence that you had really two equal tests in terms of measuring whichever construct you're measuring. And then once you've done that, then you can evaluate the reliability of the instruments by administering the alternative forms and then correlating the scores on the two different forms. And that correlation is called the equivalency coefficient. You would get that coefficient. And then the third method, internal consistency, is actually a variety of methods. Basically, usually has to do with splitting the test in half. The split half method means literally that. You take half of the items on the test and correlate the performance on that half with the other half of the test. So it could be odd items correlated with even items, or first half correlated with the second half, though that's more problematic to do it that way. But the idea is you evaluate half of the items by you correlate the performance with the other half. So there are a variety of ways you can do that. You'll also see Kuda-Richardson 20 and 21, and that approach, which is a little more intricate in that it involves variance and some things that we won't get into, but that's another way of calculating internal consistency. And then what you will see very frequently, probably more frequently than any others, is the Cronbach's coefficient method. And this is essentially a way of averaging all possible half and half variations. So there's a way that you, an equation and a way that you work this out to calculate the reliability in terms of all the possible split half methods or half and half approaches that you could take. So you'll see Cronbach's coefficient, and you'll see that in terms of the R correlation coefficient. And then in terms of validity, validity refers to the extent to which a test measures what it purports to measure or what it is designed and used to measure. Also, the extent to which inferences may be made based on the test scores depend on the validity of the test. There are three types of validity that we talk about. Content validity describes how adequately or how well the test content covers a representative sample of the domain to be tested. The test is valid if it measures the topics and mirrors the cognitive level of the subject matter presented. What that means is the test content includes questions or items that represent that construct that you are trying to measure. So if we were talking about a test for this week of the class, for example, if the items on the test were about things like reliability and validity and things that we're talking about this week, then they would represent the content that we are covering, and so they would have content validity. If they asked a lot of questions about things that we haven't covered yet, from week 7 or week 8, for example, then that test wouldn't be a valid assessment of how well you have learned the information presented in week 4. So that wouldn't have good content validity. It wouldn't be a valid test of your week 4 knowledge. You'll also see the term face validity, which basically means if you look at the content, it looks like it is measuring the construct that you're trying to measure. So on its face, it looks good. Face validity. Construct validity is the degree to which the test measures some psychological trait, construct, or model or theory that it is designed to measure. And a lot of times when a test developer, so for example, I'm developing my own test of intelligence, let's say, and I administer my new intelligence test to a sample of people. I might correlate their results with their performance on an existing and well-accepted test of intelligence. So some previously developed and well-respected intelligence test that has been accepted to measure the construct of intelligence. And if my new intelligence test correlates highly with the scores on the existing intelligence test, then you could say that my test appears to have construct validity. It appears to be measuring the trait or construct, in this case intelligence, that it is designed to purports to measure. And then criterion-related validity means the test or the instrument predicts some criteria or indicator that you're trying to measure. And we talked about predictive validity and concurrent validity here. And these are both types of criterion validity. Predictive validity, a test has predictive validity if it predicts some future performance or some future level of some criterion. So if I give you a work aptitude test that has to do with some particular occupation, and you score very highly on it, and then you go out and start working in that occupation, and you do very well in the future, then we would say my test had good predictive validity. It predicted how well you would do in the future. Concurrent validity means that at the same time, basically, at the time that you are taking the test, it is measuring your level on some criterion. So if you are very anxious, at the time I give you my anxiety test, and my test suggests that you are very anxious, then it has good concurrent validity. It is the extent to which the measure accurately estimates your current status with regard to some criterion. All right, let's talk about the various scales for measuring variables. And we will talk about 4 different scales of measurement. Remember that regardless of what type of measure we use, what type of instrument we use, or what the way we measure a variable, the goal in quantitative research is to assign numbers or put numbers on participants' responses or performance. We'll put numbers on a construct that we're measuring so that we can summarize and analyze the participants' performance or results. So researchers distinguish between 4 ways of assigning numeric values to responses or levels or scales of measurement. And these are nominal, ordinal, interval, and ratio scales. And these determine the amount of information provided by a particular measure. So these scales give us different levels of information, and you should keep that in mind as a researcher when you are making decisions about how you're going to measure variables. You need to make decisions about the level of information that you want. So for example, you could measure income. You could measure how much money do you make per year. You could ask a person that, and you could get a dollar amount, and that would be measured on you'd be measuring that variable on a continuous scale. So if a person makes $50,000, you would be measuring that on a continuous scale, and that would be pretty precise information. Another way you could go, though, is to make that a categorical variable, and you could ask, instead of how much money do you make every year, you could say, do you make between $10,000 and $20,000, $20,000 and $30,000, $30,000 and $40,000, $40,000 and $50,000, and so on. So now you've created categorical variables, and you're going to get less information. Somebody could say they earn between $50,000 and $60,000, but you don't know exactly how much. So less information if you use that sort of categorical variable. So these scales will provide you at different levels of information. Sometimes you only need categorical information. Sometimes you need continuous variable level of information. So it's just something to think about as you are designing your research study. These scales also determine which level of statistical analysis can be conducted, because some of the more powerful statistical tests require data to be measured on interval or ratio scales, so on or continuous scales. So different amounts of information will determine different statistical analyses that we can do. So those are some things to keep in mind when you're thinking about your measurement scales and designing a research study. Let's talk about these scales. Nominal scales are based on classification. You're putting people into categories, and basically what you're doing with a nominal scale is assigning a name that has no value, no mathematical value, one category doesn't count or have value higher than another category. You're just giving names to the different categories. And variables that we measure on nominal scales generally include things like gender and ethnicity and marital status. So either married or unmarried or divorced or widowed. It's just a name, and it doesn't have any higher value to be one versus another. It's just a way of putting a name and then a number on a category. Ordinal scales, on the other hand, do provide an order. They provide a relative order. There's a logical order to the categories, and there are intervals or numbers representing that order, and we can determine that one value is more or less than another, but it is impossible with ordinal scales to say exactly how much less or more. And when we look at an example in the next couple slides, you'll see what I mean. So this is an example of some nominal scale sort of items, questions we might ask. The responses would be based on a nominal scale. Which item best describes your ethnicity? White, non-Hispanic, African American, Hispanic, Native American, Asian or Pacific Islander, and other. So a person would indicate where they felt they were in terms of their ethnicity, and we might assign a number to the box that they checked, the line that they checked there, but it doesn't really have any value. One isn't higher than another. So those are just categories. And then ordinal scales, this would be an example of a Likert type scale where we measure order. So if I said, I gave you a statement like, my life is wonderful, and I ask you to indicate how much you agree with that statement, my life is wonderful. You might indicate a 5. You might circle the 5 there and say you would say 5 in response to that statement. Let's say I ask you in a couple months, and now your response is a 6. Then we could say that you agree with that statement more, you appear to agree with that statement more now than you did 2 months ago. But we couldn't really say how much more or what it really means in terms of the amount of agreement between a 5 and a 6. So it doesn't really give us that sort of information, but it does allow us to measure some degree of order there and say that one value is higher or more than another. Interval scales are scales with equal intervals or distances between the scores, and scales that do not have a true zero. So for example, intelligence test scores are generally on an interval scale. Temperature, we talk about temperature on a interval scale. These scores allow us to identify the magnitude of difference between scores, and the differences are meaningful. We understand what those differences mean on an interval scale. We know if it's going to be 10 degrees warmer tomorrow, we have a fairly precise understanding of what that is going to mean and feel like. So much more information from a interval scale. And then a ratio scale is essentially an interval scale with a true zero, and otherwise it is an interval scale. And so the difference here would be when we have a variable that where a true zero is meaningful, like for example money, you can have a true zero, you can have no money, and that's a meaningful concept. Temperature, a zero, it just means it's very cold, but it doesn't mean that there is an absence of temperature, that you don't have any temperature. So interval and ratio scales provide much higher levels of information than ordinal scales. All right, so looking at our, moving along in our list of questions in terms of our quantitative research, we just talked about operationalizing and measuring the variables. And now let's look at sampling. So in the next section, we will talk about approaches to sampling and identifying the best way to sample a population in order to answer your question.